Hi, my name is Jose, and we are going to discuss lean operations in the context of NFV, Network Functions Virtualization. And we'll do that for the purpose of delivering service agility, because launching new applications in the marketplace should be as easy as getting them deployed with just one click. Now, this is a real environment. This is not a proof of concept. These are products that are either available today or in production in 2015, namely Motive Dynamic Operations, the OSS, Nuage Networks SDN framework, the CloudBand platform, which manages the management of the lifecycle of the VNFs, as well as orchestrates the underlying cloud infrastructure. Last but not least, we'll also be discussing the findings from Bell Labs research. And to complete the environment that we are operating with today, you will see a fully virtualized radio access network, as well as the core with the Virtual IPC and Virtual IMS all working together to deliver this voice over LTE video session. We are going to follow two basic principles in this demonstration. Principle number one, these are very sophisticated systems. We are bringing them together, therefore there is no denying that we need to abstract out complexity to deliver simplicity. That way we can manage operations. Principle number two, no matter what we do in the background, operationally speaking, the user experience, the video should continue to play completely unscratched. And at the end of this demonstration, we'll review these two principles to see how we did. Deploying any application should be as easy as, and this is the virtual catalog that we have in our labs at the Cloud Innovation Center. It should be as easy as selecting what I need and launching it on the Operation Center. The heavy lifting is actually being done by the CloudBand Management and Orchestration Platform. It understands the application requirements, the life cycle. It will make sure that it talks to the right components to spin up the right virtual machine and onboard the service. Moreover, now we need for traffic to flow through this new application, this new service. So I'm going to be talking to Nuage Networks, SDN, Software-Defined Networking Framework, to get that going in a split second. So I'm going to do what's known as service function chaining. And there you are. Now, let's continue to test more things in the marketplace in real time. I'm now delivering another application, a content filter. And maybe I should deploy a WebRTC server. And here it is. And by the way, all of the virtual machines that are green are carrying load this minute. The virtual machines that are blue are actually on standby. These are mated pairs for reliability so that we can work in HA, a high availability environment. Moreover, the virtual machines that lay horizontally are actually services. These are products from third-party partners, also onboarded on the CloudBand platform. And as you see, we need to do more service chaining so that we are now getting to work with Nuage Networks SDN. I'm going to do the chaining for this one application, and everything is fully programmable, everything is fully automated. Now, let's discuss what happens when a network operator becomes victim of success. And that would be a situation where, let's say, this video service becomes very popular, it works well, and then there is pent-up demand. More users would like to use the service, and therefore traffic grows. Let's simulate that kind of situation. This is a load generator, which I'm going to work with to do a stress test. As you see, traffic is ramping up. The question is, we will have enough capacity to meet demand. Things are not looking that good, but as we detect this thanks to Bell Labs analytics, we're starting to spin up new virtual machines onboard the service so that we can get some relief, as you will see, and then start working, with new users, new subscribers, without a glitch. The opposite is also true. Let's say that there is no longer that much demand for this one service. There aren't so many subscribers. Traffic is no longer flowing through the system at the same scale. Let's simulate that. Now traffic is going down this minute, and the same way we were scaling and creating more capacity, now we are going to take down all of those systems so that we can make the underlying resources available for the next batch of successful applications. As you see, the ones in red are continuously being monitored so that we can clean up and once again terminate those services. Now, we can do all of these things because we are working in a data center environment. These are CloudBand, Cloud Nodes. This is commercial off-the-shelf infrastructure. These are not dedicated servers. Therefore, we can spin up new virtual machines, we can onboard the applications, and we can continue to reuse these resources at a very high utilization level over and over. If you are successful, in addition to experiencing demand and coping with capacity quite successfully, as we just demonstrating, at some point you'll be facing with upgrades, updates, therefore maintenance events. Let's simulate that. This is a reliability, availability, and serviceability test. We could open a maintenance window. The more applications we have, the harder it is to find those at the right time without disrupting the video experience, the user experience. We could do something that looks like a network failure, something that doesn't meet the QoS, or perhaps a cloud failure that could involve a corrupted virtual machine. Let's do that one. As you see, the machine that's compromised is being flagged. The load has already been placed on the mated pair, so there was no disruption of any kind as far as the user experience is concerned. And we have been able to do that because we are using smart placement combined with a distributed architecture. The data center on the left, number one, is actually at a central location. We have consolidated assets for the purpose of delivering cost efficiencies. Data center number two is actually at a distributed location, perhaps closer to the edge for performance sake. Now, everything that we have been discussing up to this point is available from Alcatel-Lucent's portfolio in 2015. In the next few minutes, I'm going to be sharing with you the research findings from Bell Labs projects that relate to smart load placement and autonomics, that is machine learning for NFV. As you were able to notice, as I moved the load to the other data center, the service was not disrupted, but I lost HA, that's high availability. So now I need to look for the best placement for the mated pair that will become my backup should something happen to the virtual machine that's carrying the load right now. The question is, where should I do that? So the Bell Labs recommendations engine is checking cloud requirements and conditions. It couples that with same checks or equivalent checks for network requirements and conditions. It understands what any given application needs in the lifecycle. It reads the contract, because it doesn't make sense for me to deploy something on a more expensive environment, which would defeat my business case. By the same token, I cannot deploy the load in an inferior environment that would not meet the contract, the SLA, the service level agreement. Additional policies, this could be engineering events or any other kind of rules. It could be weather conditions. I wouldn't like to move the load to a data center that's going to be compromised by bad weather or terrible weather for that matter. Now, if I like this recommendation, which is move the load from Cloud 1 to the Barcelona data center, I could just click accept and move forward. But what if there was a better option? So I'm going to ask the recommendations engine to present another option, and in this case, it's telling me that I should be moving the load to Tokyo because that's my next destination, and it makes just sense for my service to be closer to my location. In any case, at any given point of time, I should be able to do RCA, that stands for root cause analysis. And for that purpose, we can display correlated, fine-grained, correlated analytics so that we build a dynamic dashboard that we can always check to analyze the current situation and do troubleshooting accordingly. The various metrics come and are fed by the different solutions that you see represented in the smaller screens on the sides of our control panel. If this was a false alarm, then I would click on stand down and nothing would be executed because false alarms happen. If I needed more time to get more data, to do further analysis, I click on standby, and that's what standby will allow me to do. There is also research on autonomics, as I was sharing before, which means that the recommendations engine, time after time, learns from these behaviors, and it can become more predictive, and therefore, eventually, over time, it gives you even better recommendations, further optimizing system performance as well as any other kind of efficiencies. I'm going to accept the recommendation that perhaps works best for me, which is Barcelona. And in the background, what you see is the very same things that we saw a minute ago. A virtual machine is being spun up, an application is being onboarded, networks are being created, and all of that happening literally in split minutes. Very different from the present mode of operations, where it takes filling out forms, having meetings, talking to people, and maybe it's hours, if not days, perhaps weeks, before we get anything done. Here, everything is fully programmable, fully automated. Things happen in real time, as you can see by means of this demonstration. We have also brought to you a single pane of glass to abstract out complexity. When drilling down, it pays to go to the UIs of the specific solutions. This is not an Alcatel-Lucent product. This is just meeting a requirement from many of our customers who are asking for the APIs from the various solutions so that they can build their own dashboards, their own screens. Well, this completes the demonstration, and as I was saying early on, 100% real. This is no POC, no proof of concept. All of the products, with the exception of Bell Labs research that we just discussed, are currently available or in production in the year 2015. Thank you.